Not much more. And every day that you're here, that's one participation point. How exciting. All right, final review. This is it, everyone. There's no more to learn. There's just to review and be done with this class. All right, so your final is on May 10th. That is on Monday. So we're going to have review this week. I don't think we're going to have review on Friday. I think I have meetings all day on Friday, I think. I'll double check. But I think we're just going to have a review Monday through Thursday this week. All right, your final is 125 points, 25 questions. That means 5 points per question, it looks like. All right, breakdown. So your first semester, kind of funny. There's actually only one question from first semester, and it's from Unit 1. So I thought that was kind of funny. So it's your final is cumulative, but just mostly for this semester. We have one question from Unit 1 this semester. You're going to have 4 questions from Unit 2, 4 from Unit 3, 6 from Unit 4, and the most from Unit 5, which kind of makes sense because Unit 5 was the longest by far unit. Yes, Unit 5 was very, very long. Hopefully all of you listening to this and here right now, you're all done with Unit 5. I think it locks this coming weekend, maybe? Double check. So there's the breakdown. All right, I also sent everybody this review on Friday in hopes that all of you spend a little time working on some of the problems. All right, first question. Oh, by the way, the order of these questions appearing in this review are not the order that you're going to see on your final. Just like last semester too, the order that you had your review was not the same as the final. I made this review in the order of your units, so it's progressive. I felt like grouping the same concepts together and reviewing, but on your test, it's going to be mixed up. So keep that in mind. All right, so first one says asymptotes. What's the limit of the nth term as x becomes increasing large? So this is the one where you want to look at if it's you want to look at your leading term and look at the exponents. Is it bigger on top or on bottom, or is it the same? We learned in Unit 1. This is the semester 1, Unit 1 question. So this was like in September of 2020. Feels like yesterday. Well, if you remember, if the exponents are the same as x becomes increasingly large, the limit approaches the coefficient or the ratio of the coefficients. So, x squared and x squared. So this is going to be 2 divided by 1. Go to the next page here. Because if they are the same, you take the coefficients. 2 divided by 1 is 2. So 2 is the answer. This next one, looking at the x to the first power and x to the first power, hey, they are the same. Well, so that means it's also the ratio of the coefficients, and it's 1 divided by -3. So -1/3 is the limit. Next one over here, we have x squared and x to the first, so it's bigger on top. Well, if it's bigger on top, then that means, well, it's considered top heavy. The limit does not exist, so there is none. I don't know if your test is going to say none or it doesn't exist, but to some effect, there is none. All right, this last one. X to the first and x squared, well, it's bottom heavy. And you look at the bottom heavy, we learn that if it's bottom heavy, the limit is always y equals 0. That look familiar, everyone? Mm-hmm. Mm-hmm. Right. Now we're on to semester 2. From this point forward, we're going to be in just this semester. All right, Unit 1. Determine if a series is geometric or arithmetic, and then determine if it's convergent or divergent. All right. So, anybody here work these problems out? If you want time to work these out, you just want me to just go over how you do them. Is that what all of you are here for? Well, we'll do this. How about I take a poll and I'll ask all of you. So, if you want me to give you time to work these out, choose B as in boy. If you just want me to go over and actually how to just do these problems, like I did the previous problem, just choose D as in dog. Hmm. Hmm. All right, people who don't vote, I'm just gonna put B as in boy. All the no voters are count as B as in boy votes. Someone who wasn't here chose A. That wasn't a choice. Good job. All right. Looks like B's win it. So I'm going to give all of you, let's say, I was looking for the timer in Neuro, realized there isn't one. Ha ha ha. Let's do, let's do like 3 minutes. How about that? 3 minutes.
Are we doing number one or all six right now?
Well, all 6.
Okay.
I'll give you all little hints. There's your hint. Arithmetic series are always divergent, and geometric series are convergent if the absolute value of the common ratio is less than 1. So there's a little piece that you need right here. Another 40 seconds left. All right. What is the answer to the first one? First one is Antonio says geometric and it's convergent. I would agree. You know this. So when you're given a series like this, you can just look at it and just see if you can figure out if you're adding or subtracting by this, the same common difference, it's called, or if you're multiplying by the same, common ratio, this is called. So going from one to the other, this is multiplying by 1/4. 5 times a fourth is 5/4. Times a fourth is 5/16. Times a fourth is 5/64. You can also find this common ratio by taking the second and dividing by the first. 5/4 divided by 5 is 1/4. 5/16 divided by 5/4 is also 1/4. And 5/64 divided by 5/16 is also 1/4. If you guessed, you say, well, I'm going to try the subtraction first to see if it's a common difference. 5/4 minus 5 is not the same as 5/16 minus 5/4. So because of they're not the same, we know it's not arithmetic. And because the R value is smaller than 1, the absolute value of it, because it's smaller than 1, we know that it is convergent. All right, number 2. What did I get for number 2? Arithmetic and divergence. I think number 2 is arithmetic. Why is it arithmetic? What is the common difference here? So we are adding 1/2 every single time. No one's disagreeing with him. No one is disagreeing. Number 2 is right here, everyone. This is number 2. It is geometric. Number 2 is geometric. Now, a giveaway, if you notice, it goes negative, positive, negative, positive. It alternates plus and minus. So there is no way it could be arithmetic. So remember, you're arithmetic, you're either adding or subtracting by the same number. You can't alternate, you can't flip flop plus and minus if it's arithmetic. It's not possible. Yeah, so it's definitely geometric. So 4 divided by negative 3 is negative 4/3. Negative 16 over 3 divided by 4 is also negative 4/3. So the common ratio is negative 4/3. You are multiplying by negative 4/3 every single time. So this one is divergent because the absolute value of negative 4/3 is not less than 1. So the absolute value of negative 4/3 is 1 point, what is that, 1.3? And 1.3 is definitely not less than 1. So because it is not convergent, based on this rule here, it is divergent. All right, number 3. Number 3. Arithmetic or geometric? Arithmetic, yeah. Yeah, this one you are adding, looks like you're adding a half every single time. Yep, you're adding 1/2 every single time. And by definition, all arithmetic sequences are divergent. All right, number 4, which is over here. Number 4, arithmetic or geometric? Arithmetic. So what are we adding every single time then? Looks like we're adding negative 2/3 every single time. Negative 2/3. Negative 2/3. Yeah, I think I would agree with that. Negative 2/3. Yep. Is arithmetic? Is it's well, because you're adding negative 2/3 every single time. And it's divergent because, well, they're all divergent if it's arithmetic. All right, number 5. So this bottom left one, number 5. Arithmetic or geometric? Geometric? What's the common ratio then? I think that one's pretty easy to see. You know, going from this one to this one, this one to this one, I think it's pretty easy to see what the R value is, right? Any ideas? 3/5? Yeah, I would agree. Yeah. Multiply the top by 3 every single time, multiply the bottom by 5 every single time. Yep. 3/5. And is 3/5, is that less than 1? Yeah, so that would be convergent or divergent? Convergent. Yep. And number 6. Convergent. I'm sorry. Geometric or arithmetic? Mm-hmm. Yep, George, you're right. It's geometric. It's pretty easy to see. It's geometric. If you notice, it goes plus, minus, plus, minus. If it alternates like that, it's definitely geometric. It's not possible to be arithmetic. Definitely geometric. And then what is the R value? Three halves. Well, negative three halves. Yep. Yeah, you're right. Negative three halves. And is that divergent or convergent? Emily says divergent, which I would agree because the absolute value of negative three halves is 1.5, and 1.5 is not less than 1. Therefore, it is divergent. Yep. Pretty simple, I hope. Any questions before we move on? All right, all right. Okay, this is from Unit 2, standard position and coterminal angles. I think pretty easy. We've been dealing with coterminal angles quite a bit this semester in one way or another. So you're going to be given an angle, which in this case is negative pi over 4, and you want to select all of the angles that are coterminal angles. Now, one thing to note that trick people up on the quiz in this unit is you can't select itself as a coterminal angle. That's not a coterminal angle if it's itself. Sorry. So if you had if you had negative pi over 4 as one of the choices, don't select it because it's the same angle. It's trying to trick you. So which ones of these are coterminal angles? Or in other words, well, tell me this. How do you find coterminal angles? You're given this. How do you find coterminal angles? You can add 2 pi or, subtract 2 pi. So really it just comes down to typing this in and then doing plus 2 pi. Do we have one of these answers? No, yes or no, and then you select it. Add 2 pi again. Do we have an answer? Yes or no, and then you add 2 pi again, and you'll go as high as, looks like 15 pi over 4 is the highest, which is like almost 4 pi. So you probably want to maybe add 2 pi like 5 times to this to make sure you cover everything up to this value. And then start here, and then you want to subtract 2 pi and get as low as, well, this value here, which is almost, what is that going to be like? Almost 6 pi. Oh, actually, I misspoke on this one. This was going to be almost. No, I didn't. I think I read that one. Anyway, you get what I'm saying. So again, what are the answers? Which ones are coterminal angles? So Antonio, adding 180 is not correct. So if this was in degrees, you would want to add 360. Remember, full rotations is 360 degrees or 2 pi radians. So 7 pi over 4 is one of them. Yep. Emily, I think you meant negative 9 pi, right? Negative 9 pi over 4?
No, when I typed it in, I got 9 pi over 4. I probably typed it wrong. Hang on.
It's not one of the choices. That's why I ask.
Yeah, I don't know what I'm.
That may be true what you said.
I probably typed wrong.
Yeah, that might be true, but it's not one of the choices.
Yeah, hang on. Yeah, okay, now I got 7 pi over 4, so I must have just mistyped it.
Antonio, do you think or do you know? Because I think they could all be right too. But you only know unless you actually try it.
Well, I kind of have, but in my head, I haven't actually done it in the calculator.
You did negative pi over 4 and you added and subtracted 2 pi to it in your head.
Yeah.
Your brain is bigger than mine. I can't do that. So I'm going to say on your final, don't do these in your head. Write them out. Maybe write out negative pi over 4 and then do plus 2 pi, put the answer. And then put plus 2 pi again, put the answer. Plus 2 pi again, put the answer. Write this stuff out. And then go the other direction. Write out negative pi over 4, put minus 2 pi, write the answer. Do minus 2 pi again, write the answer. Minus 2 pi again, write the answer. Don't do these in your head. So Antonio, I hate to break it to you, but your head lied to you. Not all of these are the answer.
I was trying to test everybody.
Success.
There's really only two of them, I think.
Wrong again, Antonio.
Is my internet breaking out? You know, that's really the issue here.
All right, all right. Does anybody have? So, how many solutions do we have here? All right. Somebody says there. Emily, you said there's 3. Emily, you are correct. Okay, Antonio, which ones are correct? Let's see if you're right at least on those 2.
7 pi over 4 and then negative 9 pi over 4.
So the
Those
first
are
2
2
are
or 3.
correct.
Yeah.
Okay. Yeah, that one's right. Yep, that one's right. So what's the last one?
Okay, so if I had to put that, I'm gonna say 15 pi over 4.
You just okay. You saw Emily
No,
with the answer.
no, it's because they do 7 pi over 4, and then you add 8 pi over 4 to that, you get 15 pi over 4. Quick maths.
Well, so don't overcomplicate it by doing 8 pi over 4. Just put plus 2 pi, and your calculator will do the math for you.
Sorry, I have another calculator. I have to do it this way.
All right, Antonio. Yes, those 3.
Point is, Apple makes you smarter because I have to actually do it by hand. I can't just rely on technology.
Or it makes you miss more problems by some simple mistakes.
Possibly, but there's no proof to this anywhere.
All right. Next problem here we have triangle JKL is a right triangle. That angle K is the right angle. Side KL is equal to 9. Side JL is equal to 12. And we want to find the sine of J, the tangent of J, and the cosecant of L. This one's multiple choice. So these are the choices in this box. All right. I'm going to give everybody 3 minutes again. Ready to go. Another 35 seconds. All right, what is the answer to the first one? Three-fourths, Antonio says. Anybody else? Julia says three-fourths as well. So that's two people. One, two, three, four, five people. Five people are here but not here. All right, it is three-fourths. Good job. All right, number two on this page. Tan of J. Anybody have that answer? Did you draw a picture? Did you draw a picture? Antonio, you are correct. Yeah, I would say drawing a picture might be the only good way to approach this problem. All right, and Antonio or whoever, Julia, whoever's still with me, what'd you get for your last problem on this page?
That's hypotenuse over the opposite, correct?
Maybe.
If it is, then that would be. Wait, what was it for L? Can I guess?
Sure.
7 pi over 4. So rad 7 over 4.
No.
Okay, it's the other one. Then 7, rad 7 over 3.
You totally guessed, didn't you?
Yeah, I literally did. I forgot what the ratio was for that one. So.
Well, so let's kind of talk about this. So please write properly. So you have, remember, sine is opposite or over hypotenuse. Cosine should be an equal sign right there. I'm not on my Mac this morning. That's why I can't write.
Excuses.
I know.
We had an Apple calculator and a Mac advertisement today, so we should probably sponsor.
Yeah. So sine and cosecant are opposites. Cosine and secant are opposites, and then tangent and cotangent are opposites. So yeah, you just flip them, and Antonio, what you said, cosecant would just be hypotenuse over opposite.
So 12 on top, opposite of L is going to be See, the way I drew it, my opposite of L is 12. So that's what I was confused about.
Mm,
Unless the hypotenuse is whatever 12 times 12 plus 981 is squared. Is it 15? 12 over 15? That's not an option. Oh, wait, is it 4/3? We need to draw this.
well, so yeah, you draw a picture of this right triangle, and it says angle K is the right angle, which I have labeled properly. It says that side KL is 12 and side I'm sorry, KL is 9, JL is 12. I can't read. So I labeled those sides appropriately. Next, you have to use the Pythagorean theorem to find, well, the missing side, and that's what Antonio did too. So remember, it's a squared plus b squared equals c squared. So we do that math, which I show a simplified version of it, and that's how we get 3 rad 7. Antonio, do you agree with me?
Yes, sir.
All right.
This is 63. Radical 63 simplified, correct?
Yes.
Okay.
Yes.
Yeah, then I do.
All right. So looking at sine of angle J, well, sine is opposite over hypotenuse. So it's 9 over 12. Reduce is 3/4. So that's that answer. Tangent of angle J, well, angle J is opposite over adjacent. So it's 9 over 3 rad 7. 9 over 3 becomes 3 over 1. And then you have to rationalize by multiplying top and bottom by rad 7. And then that's how you get 3 rad 7 over 7. And then cosecant. So there's, I guess, 2 ways to approach it, how I talked about on the previous page, or knowing that cosecant is the same thing as 1 divided by sine, right? It's on your identity sheet. And the sine of L, so sine is opposite over hypotenuse, so 3 rad 7 over 12. Reduced is rad 7 over 4. Oh, I didn't reduce it yet. I waited. I should have reduced it. It would have been easier to look at. Doesn't matter though. I reduce it on this next step. So 12 over 3 becomes 4 over 1. Then you rationalize to get 4 rad 7 over 7.
I was close. I don't need to guess the last one. I didn't guess.
No worries.
I feel so lonely. There's nobody. I'm here on my own.
So another way, I'm going to go back on this previous page, talking about how cosecant is hypotenuse over opposite, looking back at this problem here. That's pretty much from this step here. So opposite of angle L is 3 rad, hypotenuse is 12, not 3 rad 7. Hypotenuse is 12. There's the 12. And then opposite is 3 rad 7. Hypotenuse over opposite. So really, we could have not looked at it this way and just looked at it as hypotenuse over opposite and started from this step and only, saved a couple steps. So either way is fine.
Did people really pick B, or do you just give us B because you want us to work?
What do you mean? Which one?
When you had us poll earlier, did they really pick B, or you just gave us B because you want us to work?
I want you to work.
I could tell, because I'm like, there's no way everybody picked B and then just left me hanging here to be the only one working.
You saw right through it. Next problem. Terminal ray of angle theta drawn in standard position passes through 5, -10. What is the value of cosecant theta? Draw a picture, everyone. Draw a picture. Let's do 1 minute to draw your picture, and that way we can confirm that everyone's picture is good. 1 minute. All right, everyone's picture should look like this.
I remember this now. Kind of, sort of, not really, but we're gonna fake it till we make it.
Yeah, so x is 5, y is -10. So x is 5, y is -10. So did my point there. Draw my line to it. Creating my triangle. So this is my right angle right here. Now we have to find the cosecant of that angle. Now we learned, we reviewed on the previous page that cosecant is hypotenuse over opposite, and you can check out your identity work, or I guess formula sheet that I made up for all of you that hopefully all of you still have printed. And you can look at that. Cosecant is hypotenuse over opposite. So you need to solve for the hypotenuse by using the Pythagorean theorem, right?
A square root of 125
b squared equals c squared. So rad 125, and what is that simplified?
I'm working on it. That would be a number of 5 radical 5.
Yes, 5 rad 5. So this is 5 rad 5. And I would write that in here.
You want me to write it?
Yes, please.
Got you. Here you go.
All right, thank you. 5 rad 5. So cosecant is hypotenuse, so 5 rad 5 over opposite, which is -10. Hit the wrong key. And we reduce that. 5 over 10 becomes 1 over 2. And it's negative out in front. So remember, the grading system is on the OHS. They want you to keep the negative in front of the entire fraction. If you leave on the bottom, it's not going to mark it correct. It's just how it is. Even though it doesn't matter if negative is bottom, top, or in front. It's all the same. But I prefer having it on top, but they prefer having it in front. So we go with that way. Should be pretty easy question if you have your identity sheet and you know these ratios. Cosecant is hypotenuse over opposite. You should know what your secant is and what your cotangent is. Do we have time? You know, let's go ahead and stop here. I was gonna do one more, but I think we'll stop. Time flies when we're having fun. So we will pick up off from this point tomorrow. If you can, and you're done with your Unit 5 stuff, work on the next 5 questions. So tomorrow you're more prepared and we can go through this a little faster. So I want to get through at least 5 to 7 problems tomorrow. All right, guys. Well, thanks for coming, and I'll see you tomorrow.